All right, you've got a networking exam coming up, right? Well, let's get you ready. We're going to cut right to the chase and break down exactly how your data zips across the internet, focusing on the core routing concepts that you are definitely going to see on that test. So here's our game plan. We'll start with what I call the internet's GPS. Then we'll meet our two main approaches, the all-knowing shortest path first and the more neighborly distance vector routing. We're going to put them head to head, figure out how to avoid some digital traffic jams, and then wrap it all up with the one big idea you need to walk away with.
Okay, let's dive right in. The internet's GPS. And really, to get this, we have to start with one fundamental question.
I mean, think about it. When you hit send on an email, how does that little packet of data know whether to go to Tokyo or Toronto? It's not magic, not at all. It's an amazing process called routing, and it really is like a super sophisticated GPS for every single bit of information you send.
And here's the key. Little devices called routers are making these decisions constantly. They're the traffic cops of the internet. And to make those decisions, they use routing algorithms, which are basically just different strategies for finding the best path. We're going to focus on the two big ones, shortest path first, or SPF, and distance vector routing, or DVR.
So let's tackle our first strategy, shortest path first, SPF. For this one, I want you to picture a master planner, someone who has a giant, complete map of the entire network laid out right in front of them.
The crucial thing to understand here is that an SPF router knows everything. It has the entire network map, every single connection, every other router, and the cost of each path. Now, costs could mean speed or distance or something else. But with this God's eye view, it calculates the absolute best path from start to finish before your data even begins its journey.
And the way it does this is incredibly methodical. It starts right at the source. Then it looks at its closest neighbor and jots down the cost. It just keeps repeating that process, expanding its knowledge one step at a time until it hits the destination. Then it looks at all the paths it found and picks the one with the lowest total cost. Simple as that. Let's make this real with a quick example. Let's say we want to get from router A to router D. The algorithm looks at the map and sees, okay, I can go through router B. It notes the cost from A to B is 1, and the cost from B to D is 2. So what does it do? Simple math. It just adds the cost of each little hop. 1 plus 2, which gives it a total path cost of 3. After checking if there are any other ways to get there, it locks us in as the most efficient route. Done.
Okay, now for our other approach, distance vector routing, or DVR. So if SPF is that master planner with the giant map, think of DVR as more of a local guide. It doesn't know the whole city, it just knows its own neighborhood and has to ask for directions. Yeah, this is a totally different philosophy. A DVR router has no clue what the whole network looks like. Its entire understanding of the world comes from information it gets directly from its immediate neighbors. It learns about everything else piece by piece, just through these little neighborly conversations. So this is pretty much a DVR router's entire worldview. It's super simple. Hey, to get to network 1, I need to send the data to router B. My buddy B told me it's 2 hops away. And for network 2, I'll send it to router C, who told me it's just 1 hop away. It's all just local he said, she said information. Okay, so we've got two completely different ways of finding the best path. So let's do a showdown. Let's put them side by side. And you're going to want to pay close attention here, because this comparison, this is a classic exam question. Let's stick with our analogy here, because it works so well. On one side, we have SPF, the all-knowing planner who figures everything out up front. And on the other, we have DVR, the friendly local guide who just learns as it goes by talking to neighbors. Now, let's see what that really means in practice. This table right here, this is pure gold for your exam. Notice the trade-offs, right? SPF has complete knowledge. That means when something in the network changes, it can update its map or converge super fast. But all that knowledge makes it more complex. DVR, on the other hand, is way simpler because it only worries about its neighbors, but that also makes it much slower to react to changes. And you see this in the real world. Complex SPF is used in modern protocols like OSPF, while the simpler DVRs in older ones like RIP. Now, that simple, neighborly approach of DVR, it sounds nice, but there's a pretty big catch. Relying on your neighbors is great until one of them gives you bad directions, and that's when you can get really, really lost. And this leads to two classic problems you'll be asked about. First, routing loops. Just imagine two routers, each telling the other, hey, the best way to get to the destination is through you. So a data packet just gets stuck, bouncing back and forth forever, like it's in a digital roundabout. And then there's the count to infinity problem. This happens when a network goes down, but the routers don't realize it. They just keep telling each other it's one more hop away, and the hop count just keeps climbing towards infinity for a network that isn't even there anymore.
Thankfully, engineers came up with some clever rules of the road to stop these traffic jams. Split horizon, for instance, is a simple rule. I'm not going to tell you how to get to a place if you're the one who told me how to get there in the first place. It's just common sense, right? Poison reverse is even more direct. It basically yells out to all its neighbors, hey, that route is dead, its cost is infinite. This poisons the bad information right at the source so it can't spread. These little rules are what keep the whole neighborly system from falling apart.
All right, we have covered a lot, so let's boil it all down to the essentials. When it comes to SPF versus DVR, what is the one thing you absolutely must remember for your exam?
It all comes down to this one simple trade-off. It's global knowledge versus local simplicity. On one side, you've got this high-cost, complex approach that knows everything and gives you a perfect map. And on the other side, you've got a lightweight, simple approach that's easy to run but has to trust its neighbors and can be slow to adapt. There's no right answer. It's always about what's best for the network you're building.
So I'll just leave you with this question. If you were building a network, who would you hire to run it? A complex genius or a simple, friendly neighbor? Thinking about it like that is the absolute best way to remember the fundamental difference between SPF and DVR. Keep that trade-off in your head and you're going to do great. Good luck on the exam.